Okay, so continuing on our discussion of the use of regular expression meta-characters in the use of for use within utilities such as grep, a wide variety of editors, programming languages, etc. We're discussing how these special characters in regular expression syntax can allow us to do more than match literals, but match whole expressions within one or more files. So we're now on to a discussion of character classes. Now, character classes are something you also see in the shell, the capacity to match one of a set of things. So within this character class, we have a sequence of characters, but at a logical level, what one is doing here is matching. One's treating them as a set. The ordering is irrelevant. Instead, what this indicates is that we expect a single one of the characters which are inside the brackets, regardless of order. So having a bracket, for example, with AO in it, will match either A, single character A, or single character O. So if we had a regular expression like this, the patterns it would match would be DAG or DOG. Either one of them will be matched fine, in this case in Linux.words. So for example, we see here some line that successfully matched with DAG. Here's a line with DOG, another DAG. So here we're matching a single character drawn from this, drawn from one of the characters which is included within this the square brackets here. Okay. So here we have the additional option of specifying a range within this within these square brackets. So we could say, for example, match just not one of the set, but match anything in the character range from 1 to 4. This is a character range. It's actually not a numeric range. It's a range of characters, so it includes 1, 2, 3, 4, because they're in the ascending ASCII sequence, starting with 1, character 1, sorry, digit 1, I should really say, character, I'm not sure, and then digit 2, digit 3, digit 4. So what is this going to match? What is this regular expression going to match? Well, it's going to match something where the digit from 1 to 4, in that range of 1 to 4, is preceded by one single thing and followed by one single character. By the way, these don't need to be the same character. We haven't enforced they're the same ones. Just some character here, some single character here, some single character there. Now, we have enforced to be at the beginning of the line, the end of the line, so they could be preceded by many previous things or many following things. So, for example, here, what are we matching? What is it? What pattern did it match here, such that this was a matched line? It matched this point here. So this was the preceding character, and this was the successive character. In this case, we have a situation where it's matching here this one, it matched this point, and it matched that point. For this next line down here, it wouldn't have matched this first one because there's nothing before it, but it could match, for example, the second one, and this being the surrounding characters. It would have also matched it at this point, but when it determines there's a single match at least, it outputs the line. Grep does. So here we've actually matched it at two, or it could be matched at 2 different points, but it determined there was one, and that was enough for it. Okay, so those are character classes.